guy, Richard Baitlick, and he says that IDS alerts alone are not enough. We need to take an IDS alert and we need to surround it with all this contextual data. What we really need is something called network security monitoring, which is a methodology that originated in the Air Force, and it said we need to take all of these data types. We need to take IDS alerts and full packet capture and session data and transaction logs and give all of those to the analyst and allow the analyst to pivot between those data types mercilessly. Just like the attackers are pivoting through our networks mercilessly, we as defenders need to take all this data and pivot from one data type to another to be able to fully defend our network. So how do we get NSM? Well, the open source de facto reference implementation is Squeal. Squeal has been around now for over 10 years, written by Van Bishop, a good friend of Richard's. And Squeal is awesome. It's very powerful. It gives you all of this data, all of this visibility. But what's the problem with Squeal? Has anybody ever tried to manually install and configure Squeal? David, you don't count. A couple of guys down there. How did it go?
It was rough.
It was rough.
It was rough.
How long did it take you? Did you succeed? Your time was infinite.
I was told there's security on you. Use that.
Oh, security on you? What? What's that? Okay, so Squeal. You go to the how-to, which Mr. David Bianco, who's here today, he runs this awesome wiki that has this how-to. There's this long instruction list. Do this, compile this, configure this, edit these configuration files. And that's fine for rock stars like David and Richard who can do that kind of stuff. But not everybody is tall enough to ride that ride. Not everybody has that kind of time to put all that stuff together. So this is what it looks like. So here on the left-hand side, you see your snort alert data. This is your IDS alerts. We have passive asset data, we have session data, we have full packet capture. We have agents that take that data and they send it into SquealD, which then writes it into a database. And then you as the analyst, you connect to SquealD. So it's very powerful, but it's very cumbersome to put all the jigsaw pieces together to form this wonderful puzzle called NSM. So I was looking around, I was like, there should be backtrack for blue teams. Right? There should just be an ISO image and I could just download and have all this stuff and just be able to click next, finish and have it done. So I said, okay, well, if it's not out there, I guess it's my responsibility to build it and maintain it. So started in 2008. 2009 released the very first version based on Ubuntu. It included Snort, it included Squeal. So you could download the ISO, you could click next, finish, and you would have NSM running. So I put it out on SourceForge, and nothing really happened. Nobody really cared, so I cried again. So the next year, 2010, Ubuntu released Ubuntu 10.04, their next long-term support release. I said, okay, it's time to rebuild. It's time to do a new version. So I took what I had and I added Suricata. So Suricata is an open source competitor to Snort for Intrusion Detection System alert data. And I added OSEC for host-based IDS data. So a great example of why OSEC is, you've got a web server. Chances are that web server is doing HTTPS. Traffic is encrypted. Your network-based IDS is now blind to that encrypted traffic. So if an attacker does a SQL injection attack against your HTTPS web server, you're blind to it. But if you have OSEC, a host-based intrusion detection system running on your web server, watching your Apache log files, it's going to detect that SQL injection attack, even though it occurred over encrypted traffic, right? More visibility. If you remember from the previous slide about Squeal, so the Squeal client is written in TickleDK. It's kind of old. It's not a web-based interface. So I added a web-based interface called Squirt, written by a guy named Paul Holliday. And so I put that version out there, and a couple of folks used it. 2011, that's when folks really started picking it up. Richard started tweeting about it, and when Richard, who has 20,000 followers on Twitter, tweets something, people pay attention. So folks started playing with Security Onion. And what's more than that, folks actually started deploying it. And this is kind of weird because I had originally built Security Onion just for like a training environment, like just for students in a classroom environment. I wasn't intending for folks to actually deploy it in production because I was just putting out an ISO image every couple of months. So if you deploy this in production, you've got to deploy the ISO image, and then 6 months later, you've got to wipe that box and reinstall a new ISO image. That doesn't work so well for production deployments. So I said, okay, well, I guess I have to have some kind of in-place upgrade method. So I wrote this little shell script so that folks could deploy their in-place updates. And via that method, was able to deploy some additional functionalities. So I deployed Bro. Bro is this amazing piece of software that gives you all of this amazing visibility and intelligence about what's going on in your network. And we'll talk a lot more about Bro later. Added Network Miner. It's a great graphical interface for analyzing Pcaps. Added Snorby, which is an awesome Web 2.0 Ajax, Ruby on Rails web interface for looking at your IDS alerts. So I added lots of cool stuff in 2011. Then in 2012, Ubuntu released Ubuntu 12.04, the next long-term support release. So it was time to rebuild. So I called this project BDR, the Big Distro Rebuild. Right? This consumed a lot of my time, and a lot of Scott Ronald's. He's kind of my right-hand man on the Security Onion project. He and I spent many, many hours working on the Big Distro Rebuild. Why did it take so long? Well, the first thing we did is we took every single piece of software and we packaged it. We built true Ubuntu packages hosted in an Ubuntu Launchpad PPA, so that instead of using my cheesy little shell script to do your updates, you could use the standard Ubuntu tools built right into the distro to get your updates. So we packaged all the software. That was a big job. In addition to that, while we're building from scratch, we might as well fix some architectural issues so that we can stand up to higher amounts of traffic. Well, one thing that we did is, originally for full packet capture, we were using Snort, and then we switched to Daemon Logger. But even between the both of those, they can't handle really high traffic loads, right? If you're on a small network, they'd be fine, but big networks, not so much. So we replaced Daemon Logger with NetSniff NG, the packet sniffing beast. So this thing uses 0 copy for high-speed full packet capture. It's awesome. Then right below that, you see this diagram of PF ring. Who's familiar with PF ring? A couple of folks. So the idea of PF ring is, so you've got Snort listening to your network traffic. Who can tell me one of the biggest problems with Snort? Single-threaded, very good. Why is that a problem? Okay, so you hit a certain amount of traffic, your single-threaded Snort process hits 100% CPU, and then what happens? You're dropping packets, very good. So what PF ring allows you to do, PF ring is a kernel module with a user space library that allows you to take any libpcap software, compile it against the PF ring libraries, and it acts as a software-based, a flow-based load balancer, right? So you take a gigabit worth of traffic and you cut it up into 4 chunks, and you spin up 1 Snort instance for each of those chunks, right? So now, instead of having 1 Snort instance trying to handle a gigabit and dropping packets doing so, you now have 4 Snort instances, each handling 250 megabits, and they can handle that without dropping packets. It's awesome. So we added that. And then we added ELSA. You're going to hear a lot about ELSA today. ELSA is amazing. ELSA is like a free version of Splunk, kinda, without the exorbitant licensing fees. It's totally free and open source. It's not going to cost you millions of dollars. It's going to cost you a grand total of $0. And it gives you a nice web-based interface for hunting through your logs, whether that be your Snort logs, your Bro logs, your OSEC logs, your OSEC alerts, your standard syslog, what have you. They're all going to be in ELSA. You're going to be able to search through them, slice and dice them at will. I like big onions that I cannot lie. So another thing that we did is we said, okay, we need to be able to build big sensors, lots of RAM, lots of CPUs. Well, in order to handle large amounts of RAM, we really need to go 64-bit, right? The original version of Security was just 32-bit. So we need to go 64-bit. By building all of our software into packages and hosting it with Ubuntu's Launchpad service, they build 32-bit and 64-bit automatically for us. So that's great, that's awesome. So we release an ISO image, and it's 64-bit by default. We want folks to use the 64-bit for higher performance to handle large amounts of RAM. Now, if you want to, you don't have to use our ISO image, right? You can start with your preferred flavor of Ubuntu 12.04. And that could be Ubuntu, standard Ubuntu, Kubuntu, Lubuntu, Xubuntu, or even Ubuntu server. Right? If you don't want to run a GUI at all, just run Ubuntu server and add our PPA and packages, run our setup wizard, and you're up and running. Right? As I mentioned before, we have Snort, Suricata, and Bro running on PF Ring. We have NetSniff and G using zero copy for high-speed full packet capture. ELSA, the way it's architected, it actually acts as a distributed database because by default in our deployment, each sensor runs its own copy of MySQL and Sphinx. You've got one central ELSA web interface that queries all of those in parallel, right? So you're no longer just limited to one single central database that gets big and bloated and slow. ELSA grows as your deployment grows. Here's a picture of how that works. So you start off with your master server, and that's going to run your ELSA web interface. Then you're going to start deploying your sensors. They're going to be running Bro and Snort, Suricata, and they're going to be running ELSA log nodes. And so this ELSA web interface is going to query all those guys automagically. Here's an architectural diagram of kind of the way ELSA works and how it's able to handle large amounts of logs. This is a diagram that Martin Holste put together. Martin's the author of ELSA, and he's here today. He's going to be talking about ELSA. So you're going to hear lots of this stuff. So events come into syslog-ng, and then it goes to elsa.perl, elsa.pl. It then loads into MySQL, and then Sphinx acts as an indexing overlay to the MySQL database. That's what gives us our fast retrieval speed. So Sphinx indexes and then consolidates those indexes. And then here's how it looks from a user perspective. So you as the analyst, you log into the web interface and you issue a query. Hey Elsa, tell me everything you know about this IP address or this domain name. So you issue the query, the web interface goes and talks to all your Sphinx indexes. Says, hey, do you know anything about this? So Sphinx returns back a list of document IDs. The web interface goes and retrieves those document IDs from MySQL and returns it to you as the user. And this all happens in milliseconds. It's amazing. All right, so we talked about 2012, spent all this time rebuilding the distro, doing all this big onion stuff, right? On December 31st, 2012, released that version. And 2013, here's what we've done. So as time goes on, Snort releases new versions, Suricata releases new versions, there are new versions of PF Ring, so we have to maintain those packages. So we've updated just about every single piece of software in the distro this year. And that includes everything you see there. We have our own software that we've developed for the project itself, a lot of scripts, a lot of things that glue all the pieces, parts together. Yes, we are imperfect. Yes, we have bugs, so we've fixed lots of bugs in our own stuff. We've added more knobs for tuning. So in our setup wizard, which you'll see in just a minute, we have a lot more questions now where you can control which processes are running. You can enable and disable processes. You can adjust your Pcap file size for when you're doing full packet capture. We used to default to a 90% disk threshold, so when you hit 90% disk usage, that's when we would start purging out old log files. That's now adjustable because folks, when they would deploy on older servers with smaller drives, they'd end up filling their drive up too quickly. So we allow you to adjust that. A lot of other little knobs that you can tune things with. Another big thing that we added was the vast majority of HTTP traffic today is Gzip encoded, right? So when I take and I pivot to my full packet capture and I look at an HTTP stream, a lot of times I'll see the server respond with Gzip encoding, and it's just this binary data that I can't read. And that doesn't help me as an analyst, right? So my good friend Scott Reynolds, he wrote this Bro script that automatically decodes that Gzip encoding, so that gives me more visibility into what's happening. So we added that, and it's pretty amazing. I use it every single day. So some metrics about the project. The old version of Security ID based on Ubuntu 10.04, we had 37,000 downloads of that from SourceForge. We released the new 12.04 ISO image on December 31st, 2012. So far, we've had 34,000 downloads of it. In June, I released a 12.04.1 ISO image. We've had over 7,000 downloads of it. A .2 ISO image came out in July. We've had over 5,000 of it. And finally, because we also have BitTorrent available, and we have no numbers for how many folks download from BitTorrent, we also, if you choose to install your own version of Ubuntu and add our PPA, we have no counters for that. So suffice it to say, we've got a lot of users. all over the world running big deployments of security onion. So that brings us to today. Today I'm very happy to announce a brand new ISO image, 12.04.3. Brand new, the new hotness, right? So we have many changes since the last ISO image that we just put out. One big change is we added this new script called SOUP, Security Onion Update. Makes your life a little bit easier when it comes to updating a sensor so that you don't have to worry about PF ring and MySQL updates, which could kind of cause some problems sometimes. So we just went ahead and fixed that. We added new versions of PF ring, Snort, Suricata, Swerve, Cappy, Network Miner, and the Security Onion Bro scripts. So all the latest and greatest, all the new hotness. That's out today. One of the big new things that we just added that's included in the ISO image is salt. Anybody familiar with salt? A couple of folks. David is, obviously. Let me ask this question. How many folks are familiar with Puppet? A few more folks. Salt is kind of like Puppet. Okay? It's a means of doing configuration management and remote execution for your entire deployment. Right? So it's one thing, if you're just running just a small standalone sensor, that's no big deal, right? You can manage that. But as soon as you start running like 10 sensors, 20 sensors, 50 sensors, like, are you logging into each one of those and updating it manually? Are you, logging into each sensor and updating your configuration files manually? No, that would take forever, right? So we need a way to be able to push configuration and push updates to all of our sensors at one time. Salt allows us to do that. So with our ISO image and what you'll see in the demo in just a few minutes, your master server becomes a salt master. So the setup wizard is going to ask you, do you want to enable salt? You say yes, and it makes your box a salt master automatically. Now when you build your sensor, it's going to ask you, do you want to enable salt? You say yes, and it enables the salt menu. And it configures it to talk to your salt master, and it sets up the authentication and all that stuff auto-magically. So all you have to do is say, yes, I want to enable salt. And then, what can you do? Well, out of the box, you can, from your master server, you can say salt star, meaning all salt instances, command.run, and any command you can think of. And then that salt master is going to tell every single salt minion to run that particular command on every single box instantaneously. You can also do things like when you update your rule set up here on the master, your minions are going to be watching that rule set, and if it changes, they're checking every 15 minutes. They'll automatically pull that rule set, automatically recheck your processes for you. And then finally, another thing that you get out of the box is user management, right? So you go to your master and you say, okay, on my sensors, I want a Doug user, I want a Richard user, I want a David user. And I'm going to put my SSH public key on the master, and it's going to push out those accounts and those keys to all boxes. Automatically. Just happens. It's awesome. So that way you can manage your deployment versus having to manage individual boxes. All right, so just a quick review of some of the data types that we've talked about, some of the data types that you're going to see in the demo. So again, we start off with alert data. So we have network-based IDS alerts coming from either Snort or Suricata. We have host-based IDS alerts coming from OSEC. We have syslog data. So you can, any of your infrastructure in your environment that speaks syslog, you can just send it to ELSA, and it'll just accept it, because it's just syslog AG. We have asset data coming from Bro and Prads. We have session data coming from Argus, Bro, and Prads. Then we have transaction data. So Bro is creating all of these insanely detailed transaction logs like HTTP, FTP, DNS. So how many folks today have a log of every single DNS request in your environment? Not too many folks. How many folks would like to have that? That should be everybody. Okay? We can do that. You can do that today. Full content data from NetSniffNG, and all this just happens out of the box. All right, so would you guys like to see a live demo? Yeah. Are you sure? Yeah. Okay. Well, you made me do it. All right, so let's see. So here's our Security Onion virtual machine. This is using the brand new 1204.3 ISO image just released today. So if it crashes and burns, I'll just call it beta software. So what I've done so far is I've run through the standard Ubuntu installer to install it to my virtual machine. I've rebooted into that installation. I've run through the first phase of our setup wizard, and what that does is you tell setup which interface is which. So you have a management interface, and then you have a sniffing interface. So I've done that and I've rebooted. Now I'm going to run through the second phase of setup. Let me just make sure. Okay. All right, so here's our lovely setup wizard. Welcome to Security Onion Setup. Would you like to continue? Well, yes, I would. All right, so setup detects that I've already configured my network interfaces. So it says, do you want to skip that part, or do you need to reconfigure? We'll just skip it, because we've already done it, and it's fine. Now, the next question is, do you want to run quick setup or advanced setup? Now, for those of you who've never used Security Onion before, if you're going to try it today, we recommend that you run quick setup the first time that you try it. It's going to ask you the minimum number of questions. It's going to choose some smart defaults for you. It's going to turn everything on so that you just get up and running as quickly as possible. What I'm going to show you today is advanced setup, because this is what you're going to use if you're going to do a true enterprise production deployment. Advanced setup is going to allow you to specify this box is my master, these boxes are my sensors, they're going to report back to the master. It allows you more control, more knobs for tuning, so that's what we're going to do. Advanced setup. All right, so what kind of box is this going to be? Is it going to be a server, or is it going to be a sensor? Or you could do both and just be a standalone box. And that's what we're going to do. So we're going to do a standalone box. What would you like your Squeal username to be? What's your email address? What do you want to set your password to? Confirm your password. Which IDS engine would you like to use? You can use either Snort or Suricata. It's up to you. We'll choose Snort. Which rule set would you like to use? So by default, we give you Emerging Threats GPL. It's totally free. You don't have to sign up. You don't have to create an account. You don't have to pay any money. It just works. So that's what we'll use. But if you want to go with Emerging Threats Pro and pay money to them, you can do that. If you want to pay money to Snort for their subscriber rule set, you can do that. Which network interface should be monitored? On this machine, Ethernet 0 is my management interface, and Ethernet 1 is my sniffing interface. So we're going to choose Ethernet 1. All right, so here's where we get into enabling and disabling processes. So it's going to ask you for each of the processes in our stack, do you want to enable or disable? So do you want to enable the IDS engine? Yes, I do. This will give us our IDS alerts. So now the next question is, this goes back to the PF ring stuff we were talking about before. Because this virtual machine has 2 CPU cores, I can choose up to 2 Snort instances to run. And setup is going to configure all that automatically. In this case, I'm just going to choose 1. Next question is, would you like to enable Bro? Bro is amazing. Yes, you do want to enable Bro. And again, with PF ring, we could choose up to the number of CPU cores that we have. For this demo, we're just going to choose 1. HTTP agent, so when Bro is sniffing your traffic and it's writing all your HTTP transactions into http.log, we have a process called HTTP agent, which can take those HTTP logs and send them into the Squeal database so that you can view them in your Squeal console. So do you want to enable that? Yes, I do. Would you like to enable Argus? For this demo, we don't really need that, so we'll turn that off. Would you like to enable Prads? Prads gives you session data and asset data. So we will enable that. Would you like to enable full packet capture? Yes, I do. Yes, you do want full packet capture. How big do you want your Pcap files to be? So when it's recording full packet capture, by default, we're going to grow that Pcap file to 150 megabytes and then roll to a new file. We'll just accept the default there. At what % of disk usage would you like to begin purging old logs? So our default is 90. As soon as you hit 90% disk usage, it's going to start purging out those old Pcaps and those old log files. Would you like to enable Salt? Yes. Just be aware, though, that currently this is a brand new integration that we have. It is still considered experimental. We are going to enable it today just so you can see it. Would you like to enable ELSA? Yes. Yes. Okay, so now we come to our confirmation screen. So setup has collected all the information it needs, and it's confirming all of our selections. Are you sure this is what you want to do? Yes, please. All right, so right now it's set up behind the scenes. It's going and putting together all the pieces in that jigsaw puzzle. It's doing all the hard work for you, configuring all the stuff, starting all the processes. So right now it's initializing the Snorby database. As soon as setup finishes, I'm going to show you 4 interfaces. And the first one I'm going to show you is Snorby. I mentioned before, Snorby is Web 2.0. It's Ajax. It's Ruby on Rails. It's got all the hipster buzzwords, right? It's written by a cool guy named Dustin Weber. And it's really awesome. It's really a beautiful web interface. Folks really love it. It's one of those things when I show Snorby to folks, they just kind of start drooling. You know, they get really excited about defense just because Snorby is so cool looking. And then we're going to move on to Squirt, which is another web-based interface. Is there a question?
Yeah, I just had a couple. As far as packet capture, does it do all packet, or can you set it to do selective packet? Because I mean, if you're talking about a gigabit interface, you're going to get an awful lot of packet data.
Right. So you can. The question was, are you recording all packets, or can you selectively change what you're recording? So you can use BPFs, Berkeley Packet Filters, to say, I want to ignore all this traffic from my backup server. I want to ignore this traffic over here. I want to ignore traffic on this port, which is just doing encrypted traffic. So you can configure that. All right, so the setup wizard is now complete, right? We didn't have to spend hours and days and weeks compiling all this software, configuring all this software, testing it, and getting it to work. We're done. Right? We clicked a few buttons and we're up and running. So setup is now complete. We click OK. Just some closing information so you know where to go from there. And if you have questions or problems, you go to our site, check out our frequently asked questions, yada, yada, yada. So we're done. So let's go to our terminal window. So the first thing I want to show you is this new Salt integration. So remember I said that with Salt, from your master server, you can control your entire deployment. So what we can do is we can do something like this. Salt star, meaning all the Salt minions in our entire deployment, test.ping. And that's just going to ensure that all of our minions are up. So if we had 10 sensors, you'd see them all listed there. You'd see sensor 1, sensor 2, and they'd all respond with true. So, well, that's not that really powerful, other than just making sure they're there. But what if we do this? Command run service NSM status. All right, so obviously this is just one box, but if we had 10 sensors, you'd see the status of every single one of those sensors, all laid out for you. Sensor 1, sensor 2, sensor 3. But you can tell here that our setup process did complete successfully because we've got nice, pretty green OKs. Everything is up and running. Everything works. It's great. All right, so we've got all of these processes listening to our network interface. But they're not actually doing anything right now because I don't have any traffic, right? I'm not connected to a network. Lucky for you guys, I happen to bring some traffic, okay? So we're going to use our old friend TCP replay. And we're just going to do a small sample. I just want to make sure that Bro is doing what it's supposed to be doing. All right, so you can see there, this is the Bro con log. This is connection records. This is session data. This is this IP address, talk to this IP address. And I just wanted to verify that Bro is up and running and that it did identify our host name and interface. Everything looks good. All right, so the next thing we want to do is create some more traffic, some more interesting traffic. So we'll do this one, and we'll do this one.
Keita,
yes?
while you run this, could you explain the difference between what you're doing and people who want to use it as more of a forensic tool, how that's kind of difficult?
Yes. So what Richard's referring to is the fact that we're using TCP replay to take some Pcaps and replay them to an interface. So this is great for doing a demo like this because I'm just shoving some traffic to an interface just so I can generate some alerts, generate some logs. But you have to be careful if you're relying on TCP replay from a forensic standpoint, because what TCP replay is doing is it's not looking at the timestamps that are in those Pcap files, it's just taking the data and just shoving it into the interface as quickly as possible. So in a minute when we go and look at these interfaces and we look at the timestamps that are on those logs, those aren't the true original timestamps. Okay, so if you're working in investigation and somebody sends you a Pcap and we want to do forensics, and you use TCP replay, don't rely on those timestamps that you get out of the end of that, because those aren't the true original timestamps. Is that what you were referring to?
Yes. But there are tools that are included here, like you can run Bro against a trace, you can run Network Miner, but it's just a different operational model.
Right. So you could do, if you do want to get the original timestamps, you can do bro-r in the name of the Pcap file, you can do snort-r in the name of the Pcap file, and you can read them like that. But in order to be able to show our entire stack and do this demo today, we're using TCP replay. We don't really care about the timestamps for this demo. All right, so we've created some traffic. So now we're going to start looking at some interfaces. So I said I'm going to show you 4 different interfaces. I'm going to start with Snorby. So I double-click my Snorby icon. Proceed anyway, even though that Doug Burks guy is trying to own me with false certificates. All right, so here's my nice, beautiful Snorby interface. I'm going to log in using the username, the email address, and password that I specified in setup. Now we've got this nice dashboard. We need to force a cache update. This will take just a minute. So we've got all these IDS alerts that are sitting there in the Snorby database, and we just have to refresh. So there on the screen, you see we've got 368 high severity alerts, 46 medium severity alerts, 72 low severity alerts. We can click on each of these and we can just drill into just the high severity alerts if we want to. We can go down here and we can look at this. We can look at severities. We can look at protocols and signatures, and got nice, pretty, colorful charts for the management types, right? So that's all fun and good, but we're analysts, right? We want to see the packets. We want to see the alerts. So let's go to events. So here are our IDS alerts. So keep in mind that Snorby is really limited to just IDS alerts. So everything that you'll see here, we'll see like ET, this is emerging threats. This is our emerging threats rule set. And GPL, these are standard GPL rules. So we could find something in here and we could drill into it and start working an investigation. So let's pick this one. So this is emerging threats policy suspicious.doc.exe in an HTTP URL. So somebody tell me why I would care about that particular alert.
Social engineering.
Social engineering? Okay, explain.
That's standard phishing fare. You give it an extension so it pops an icon, people think it's a doc file or whatever. They open it, it's actually an executable, and now they're owned without having to use an exploit.
Yeah, so maybe they receive an email that says, hey, I found this confidential document from HR that talks about the fact that you're getting fired next week. Click this link to retrieve the Word document. So the user says, oh, I'm getting fired? I better read this Word document, right? So,
but our users are better than that. None of our users would actually.
Oh, clearly, yes, obviously. Sure. So here's our IDS alert. Here's our standard IDS alert type data, right? So up here you see like the source IP, the destination IP, the source port, destination port. Down here you've got the payload. So the thing to remember about an IDS alert is that it's just a snapshot in time, right? So here's an analogy. You've got a house, you want physical security for your house, you get a security system. They come and install it, and then you realize it's just a motion-activated camera that takes a snapshot. So you don't know if the bad guy knocked on your door and walked away, or if he broke down the door and stole your 3D TV, right? So look at this, and let me click on ASCII so we can just concentrate on this. So let me show you one other thing. We can look at the rule. So here's the IDS rule that generated the alert. So the IDS rule is just looking for content.doc.exe. Okay? So let's start asking some questions. So based on the IDS rule that generated this alert with this payload, was this a false positive or a true positive? True positive. Very good. This is a true positive because all it was looking for was .doc.exe, and it's right there. It's a true positive. Did the user actually download this file based on what you see here?
It made the request.
It made the request.
We don't know that it came back.
We don't know that it came back. It could have been a 404 on the server, right? So just based on the IDS alert alone, we don't know if this succeeded. We don't know if the user downloaded the file. That's when our other data types come in handy. So let's take this IDS alert and let's pivot to another data type. So we can go to Packet Capture Options, Custom, Fetch Packet. So we're pivoting to another web interface called CapMe. And so this is going to our full packet capture store and retrieving the entire TCP stream from disk. Right? So let me scroll down so you can see this. So up here at the top, you see what we saw before in Snorby. You see the GET request from the workstation, right? And then you see the server's response. What can you tell me based on the server's response? The server had the file. The server sent the file to the workstation. Okay, we answered a question. That's good. All right, so let's continue scrolling through here. So what is this? Anybody?
It's an HTTP method for setting up end-to-end communications through a proxy.
Say that louder.
It's an HTTP method for setting up end-to-end communication through a proxy.
An HTTP method for setting up end-to-end communication through a proxy. Well said, sir. You must know what you're talking about.
Yeah.
All right, so we see that in the executable that the workstation downloaded. What else can we see? What is this?
CNC IP?
An IP address. Interesting. All right, well, let's copy that IP address. Let's go back to Snorby. So Snorby, you can search. So let's say if the source address is this, or if the destination address is this, search. We get nothing. Okay, so I chose this example for a reason, because remember I said Snorby is limited to IDS alerts, and that's it. If you're just relying on IDS alerts, you're not going to solve this investigation. Okay? So let's move on to our next interface, which is going to give us a little bit more data. Let's peel another layer of the onion. See what I did there? You guys catch on fast. I can't get anything by you.
You keep peeling and you're not going to have any onion left.
Oh, just wait. I got lots of onion. All right, so I go to Squirt and I say IP is this. And then I go update. Oh, wait. There we go. All right, so Squirt has some other data types. So in this case, what we're seeing here is a PADS new asset alert. So this is asset data coming from a tool called PRADS. So PRADS saw, hey, there was a communication with this IP address, and we saw an HTTPS client. Well, that's interesting. So we did have communication. So the workstation requested the executable. We saw that it downloaded it. We saw an IP address in the executable. Now we're seeing traffic to that IP address. We're pulling the string, right? So that's pretty cool. So what about this? What if here's my workstation IP. What if I ask Squirt, hey, Squirt, what do you know about this IP address? So we have some URLs, we have some other alerts, we have a rat. We have ghost rat, command and control. Well, that's interesting. So, you know what? Let's go into Squeal. Let's peel another layer of the onion. Right? Because Squeal is going to give us a little bit more information, more access to more data. All right, so let's sort by port. And hey, here's our IP address, and here's port 21. Well, that's interesting. So our suspicious workstation IP address connected to an FTP server. Well, let's check that out. So in Squeal, you can pivot on anything that you see in here to full packet capture very quickly and very easily. Bam, just like that. Right? So this window pops up with a nice ASCII transcript. So now we see the FTP conversation that took place. So what do we see? We see the workstation logs into the FTP server with user jack password 2. Awesome. Yeah. I like this attacker. And then what do we see here? That would be an upload. Interesting. What do we see here? Another upload. Okay. That's interesting. Maybe I need to check those out. So let's pivot. Let's take the destination IP address and ask Squeal, hey, show me all of the session data for that particular IP address. And so what do we see here? Well, we see the port 21 control channel conversation that we just looked at. What else do we see there? Data channel. Interesting. What might we see in the FTP data channel? Let me look at the other one first. So what do we see here? Somebody was trying to run gseg dump. What is gseg dump used for? Dumping password hashes. What do we actually see in the output here? Do we see password hashes? We see the options for the gseg dump command. Let me offer a theory here. Might this be a sloppy attacker who actually mistyped his command? Could be. I love seeing sloppy attackers. It's awesome. They're human, just like we are. It's fine. It's cool. All right, well, let's look at the other one, okay? Because that data doesn't scare me. It doesn't scare me that they ran gseg dump and didn't get anything because they screwed up. But let's look at the other one. What do we see there? A RAR file. Wow, how do you know that?
I have eyes.
You have eyes. You can see the fact that the file begins with RAR. Wow. Can you do that again, please? RAR. Thank you. Go blue team. All right, so we have a RAR file. Well, that's interesting. Maybe I better look at that. You think? All right, so here's what we can do. We can say, instead of just looking at the transcript, I want to send that Pcap into Wireshark. So has anybody ever played with this little tool called Wireshark? Anybody heard of it? All right, so, oh, that was the wrong one. I thought it looked sloppy defender. Watch it, watch it. I will kick you out of my talk. We'll revoke your BSidesAugusta privileges as well. All right, so there's our RAR file. Sloppy defender wins. All right, so what I meant to do there was follow TCP stream and save as. Let's save this as out.rar. Close this and close Wireshark. So guess what? We just extracted a file from a Pcap. So now if we go to Accessories File Manager, and we go to File System, and we go to Temp, and we go down to out.rar, it prompts for a password. An encrypted RAR. That's crazy. So we're dealing with a sloppy attacker, so maybe he was sloppy in picking a password. How about that? So QWERTY. Bingo! All right, so we open up this folder. Hey, there's the data that was just stolen from your network. We answered that question. The attacker got in, they got the data out. There it is, right there. All right, so the other thing that I want to show you about Wireshark, or excuse me, Squeal, is, so let's pick an EXE. So we can pivot this into Wireshark. So if you see a user download a suspicious exe like we saw before, of course with Wireshark you can go File, Export, Objects, HTTP. It'll carve that executable right out of HTTP traffic. You can save that to disk, start doing forensics on it. The other option is, instead of sending to Wireshark, you can send to Network Miner. Network Miner automatically extracts the files. All you have to do is right-click on the folder. There's your executable. Pretty cool, right? All right. So that's what I want to show you in Squeal. Next, and finally, I want to show you ELSA. So ELSA is this web-based interface for hunting through all your logs. And we log in using our standard username and password. And so I'm going to show you a few different log types that we have available and how you can use those for hunting. Because what we've done so far is kind of alert-based, reactive detection processes. But you heard Richard talk this morning in his keynote speech about hunting and how we need to be proactively hunting in our environment. So in ELSA, we can say, hey ELSA, show me all of the connections on my network. So show me the bro con log. Now, ELSA, take and group that by source IP. So this is all of the top talkers on my network in just a couple of clicks. Go back to this original tab, group by destination IP. Here are all the top destinations on my network. Go back here, group by destination port. Here are the top ports on my network, right? You expect to see like 80, 53, 443. Then you start looking for anomalous port numbers, right? You start pulling the string on those. Let's look at another log type. Let's go to, remember I asked before, how many folks have access to all of the DNS requests on your network? Check this out. Show me all the bro DNS logs. Submit. Now group by host name. Check that out. That's a list of all the DNS requests on our network. You see some other stuff in there like workgroup and MS Browse. It turns out Bro also does this other cool thing where if it sees a Windows NetBIOS name request, it'll actually log that to the DNS log as well. If we just want to see true DNS requests, we can filter on port 53. So there's our DNS request. So you can start looking through that for anomalous DNS requests, start drilling on those. Now let's look at HTTP logs and do the same thing. Also show me all the HTTP transactions on my network. And oh, by the way, group by site. Okay, so this is cool. Look at all the sites on your network that your users visit. Oh, we have Apple. We have Apple. We have Apple. We got some fanboys. What's after Apple? .ru? Well, what is this thing right here? Splitme.com.cn? Well, that's clearly legitimate, right? Maybe I need to drill into that and check it out. All right, so here's all the requests to splitme.com.cn. So now if I see an HTTP request that interests me, maybe I want to drill into that. So I click Info, plug in, get Pcap, put in my username and password, wait a few seconds. It's going to go to my full packet capture store, retrieve the entire stream, and show me exactly what happened. All right, so if I scroll down here, I see a request from the workstation, I see a response from the server, I see a request from the workstation, I see a response from the server. What is all this stuff down here? Encrypted? Encoded. Gzip encoded. Remember I mentioned before that the vast majority of HTTP traffic is Gzip encoded because providers want to save on their bandwidth. So they encode it using Gzip to compress it before they send it. So I can't read this. I can't see what happened. But guess what? I can solve that problem for you. I just go back. I render the transcript with Bro. Now Bro is going to automatically decode that Gzip encoding. So now when I scroll down here, what do I see in the server's response? Obfuscated JavaScript. Very good. David has looked at this once or twice. All right, so again, more visibility equals more wins for you defenders. All right, so that's ELSA. So I showed you all this cool stuff. And oh, by the way, ELSA does have dashboards. That's pretty cool. And let's see. So now that I have preached to you the gospel of Security Onion and you're ready to download it, just go to securityonion.blogspot.com. You'll see my latest post from from 5:30 this morning, where I released the brand new 1204.3 ISO image. You can download it from there, from SourceForge or via torrent, what have you. You can get help on our frequently asked questions, on our mailing list. You can hop on our IRC channel. Follow us on Twitter at SecurityOnion. I'm teaching a class in Memphis next month. If you're interested in log management, I'm teaching that. I'm going to be teaching another 8-hour SecurityOnion class right here in Augusta, Georgia, probably in the next month or so. So if you need training, we got it. Is there a question back here before I move on?
Yeah, just curiously, instead of using ELSA, I mean, I realize it's integrated and all, but if you have an enterprise SIM deployed, can you send the logs off of Onion into
Sure.
that SIM so I can get like the pro
Yes.
logs and so on?
So the question is, if you already have an enterprise SIM deployment and you don't want to use ELSA for whatever reason, yes, you can configure all of your log data to be shipped off to some external syslog collector. That's no problem. We have lots of users that do that.
Okay, so it will export syslog.
Sure, no problem. All right, now, one more thing.